Thanks for joining us today. I'm Luke and this is Simon, and we're going to talk about infrastructure environment progression with Terraform. But first, a little bit about us.
So, we're Enabler, a consulting company, and we mainly specialize in helping our clients create platforms using GCP, Kubernetes, and AWS.
In working with our various customers, we've seen a bunch of different ways of doing this with Terraform. Today we'll talk about some of the characteristics we've noticed that good approaches seem to have in common. We'll go through a few of the approaches we've seen and try to identify where they fall over. And then we'll go into a little bit more depth about our favorite way to do this.
Why are we here talking about effective environment progression? That's
a good question. Before I answer that, let's take a little step back to talk briefly about DORA, as I'm sure many people here know. DORA is a research-based organization that has identified 4 kind of key measures of high-performing teams. So they've found that if teams are able to do frequent deployments, then they're able to introduce changes much more rapidly. If they have minimal lead time to change, then they're able to get the value from changes much more quickly. If it's quick to restore after a failure, then customer impact can be minimized. So again, you can push out changes more quickly with less fear. And if there's a lower change failure rate, then things are going to go wrong far less often. Yep. They've found that infrastructure as code is a key driver of these. If you have good practices here, you can improve all 4 of these measures. Yeah. I'd also recommend that as you try to make improvements to your environment progression and to anything with your infrastructure as code, that you find ways to continuously measure these, because if you make changes, you do want to see one or more of these improving. And if you're not seeing, if you're not measuring these, then how can you tell whether you're going in the right direction?
So, what does good look like? So first we want to start with some simple, consistent code and layout. It's quite important to structure your code in a specific way when it comes to Terraform, because once we start growing our Terraform repo, things can get out of hand quite quickly.
That's right. We want to make it as easy as possible to add new functionality over time, so it should be obvious where and how to extend things. Related to that, we also want to keep our environment-specific code to a minimum. We want to limit that really to just a handful of environment-specific Terraform variables if we can.
That's right, Luke. So the key point there is keep your code dry. So the other thing we want is minimal blast radius. So what does that mean in Terraform? That means keeping your Terraform state into smaller bits, into logical groups like applications, clusters, networks, stuff like that.
Yeah. It also means having a separate state file for each environment. It's also really important that if we're going to have this environment progression, that we actually take a change and progress it through environments. What we don't want to do is take a change and copy paste it from environment to environment, or do something that looks like the same change in each environment. We want it to actually be the same change applied in each place.
That's a good point, Luke. So the other good point is automation. Automation is pretty much what brings it all together. Continuous integration and continuous deployment. We want to be able to deploy all the way to production, moving from dev, test if you have it, non-prod, pre-prod if you have it, and then production, all in one go.
Okay, so now we'll have a look at some of the different strategies we've seen teams take to deal with this, and some of the challenges that we've experienced in doing it.
So one of the things I've seen is straight into production. Now, is that a good thing? Probably not, because you've got nowhere to test. And of course, well, what can go wrong when you're testing in production? But some of the things that we can tick off here are look, your code layout's probably going to be nice, clean, because you've only got one environment. You're probably going to have minimal repeating code, because once again, you've got the one environment. You're not going to be able to apply progression through your environments because you've only got one environment. And then when we get to continuous integration and deployment, yeah, you can do it, but once again, it's only one environment. And of course, your blast radius will be minimal because, yeah, guess what? You've got one environment.
So maybe you've grown a little bit beyond just having the one environment, you want to add a second. One of the ways we've seen this go wrong is people take their existing Terraform config and just add additional resources in there for more environments. So that's already starting to complicate your code layout. It's increasing the blast radius, because if you get something wrong, you're going to get it wrong for all the environments. It makes it really hard to be sure that you're testing the same change in each environment.
So another thing that we usually see is when people start splitting out their environments into different repos. Now, why is this bad? This can be bad because you're pretty much copying and pasting each and every one of your environments into different repos. This means a lot of copying and pasting. Your code's going to be repeated across each and every environment. So what's going to happen is your environments potentially can come out of sync. So you might have a database in dev, but you might not have it in test. Something like that is very easy to do, and it's a common occurrence when you have separate repos. The other thing is continuous deployment. You can't have continuous deployment if you've got different repos with different code. So you're not going to be able to progress your change through each and every environment. Additionally, continuous integration needs to be, once again, copy and pasted in each repo, potentially causing issues there too.
Yeah. So another variation on this is, rather than splitting out to separate repos, keeping it all within the same repo and having separate independent directories within the same repo. So it might be a dev directory with all of the config for dev and a copy paste of that for production. And again, a lot of the same challenges where these are independent things that evolve separately. Doing any kind of progression is entirely dependent on people remembering to make exactly the same changes in each one at the right times. So yeah, we definitely don't recommend this approach.
So another thing we've seen is separating the environments via Git branching. Why is this bad? This is bad because your branches can get out of sync quite quickly. We're all human. We can't remember what we've put into dev and then got to put it into test and prod and the rest of it. We'll forget sometimes. The other thing is that each branch, you might try and sync each branch together. For example, trying to merge prod into pre-prod, pre-prod into dev, and you'll have a lot of challenges, a lot of issues trying to merge those code bases together. Continuous integration and deployment potentially could be done, but you're still going to have issues because once again, you've got to change branches and you're going to have different code bases.
Another way we've seen, and I was quite surprised when I first saw this approach, is to have the same code used for each environment. You might even have the minimal variables for environment-specific variables. But then when people come to deploy into each environment, the way they manage introducing changes is to pick specific resources to target. And this has, some of the same challenges as earlier, but with another layer of complexity in that, there's getting the code in the right places, but then there's also remembering to put the right things in the right places, which goes about as well as you'd expect.
The other thing is, can you remember what you've put into each environment?
No.
No, neither can I.
So what can we do about this, Simon?
Well, what can we do? We can have a look at the code structure and the layout. So We need to start off by making sure that we have the same main TF file across every environment. Why do we want that? We want that because that will ensure we have the same building blocks for each environment. We're not trying to copy and paste from environment to environment. We're creating the same thing in each environment. Next, we want to make sure we group our state file into logical groups like networks, clusters, projects, applications, you name it, we can do it. So the code on the left, if you have a look, it groups a cluster and a network. We've added it in the one repo, but it can be in separate repos. And we want to make sure that we keep the state file small. Why is keeping the state file small? Well, it ensures that you can continue to deploy at speed. When your state file gets big, unfortunately, pulling state from a remote bucket and then going to your desired cloud can take a bit of time. So keeping it small increases speed. Next.
Also blast radius.
And yeah, it reduces the blast radius. Thanks, Luke. So next we want to keep our code dry. Now, what does dry mean? Dry means don't repeat yourself. Why is this important in Terraform? Because if you repeat yourself, there is potential for environment differences. So if you don't repeat yourself, you may avoid those pitfalls. Next, we look at trunk-based deployment. Now, trunk-based deployment is pretty much the only way to go, in my opinion. Using any other form is not great because you kind of split out your code into different branches and you end up having lots of mess by trying to keep those branches in sync. So all we're doing is creating features off the main. Once we're finished with that feature, merge it back into main, deploy to all environments. Finally, if you need, and this is only if you need, I wouldn't suggest this doing this at all and all the time, but you can do feature toggling. Now, feature toggling, if you wanted to poke out something in dev and then potentially progress it through each environment because you want to be a bit cautious, you can use feature toggling. There's a bit of a code snippet there which just uses the count function with a ternary and an environment variable to do that.
So another thing to consider when building this stuff out is the use of modules. As Simon showed before, if we focus our state files around logical groupings, that helps a lot. We can also take a similar approach with modules and build them around logical reusable components. So you might have one for GKE, for Kubernetes clusters. You might have another for a database, for instance, for an application. Again, the structure here becomes important over time. If you've got a consistent, well thought out layout for that module code, it makes it much easier to extend over time. You have kind of, as I'm sure people here know, you have two choices here. You could either do local modules if you just want to use something within a repo and you want to dry your code up a little bit. That's an option. The downside here, though, is that as you change that, the changes are going to be picked up everywhere that local module is used. To get around that, you can move that module out to be a remote module, store it somewhere else, and then you can version that and have a bit better control over how new versions of it are introduced. The trade-off there, though, is obviously you get a little bit more complexity. Something we've found works quite well in modules is to be quite opinionated about what defaults you provide, even what things you make as config options, and minimizing the amount of things that can be configured helps, because it's much easier to add a config option later when it's needed than it is to provide them all upfront just in case someone needs it, and then if you want to try and remove those later, it's quite difficult.
So, workflows and pipelines, one of the key points that I think is an absolute must when it comes to Terraform. So small frequent changes that are safe is the goal. So we want to try and deploy as often as possible with tiny little bits of code. Because if your code is small and you deploy it, smaller blast radius. And how can we do this? How can we achieve this? Automation. So we want to automate it as much as possible. This starts off with CI, and it's a very important step, CI, when it comes to environment progression, so that we can potentially do a hands-off deployment all the way to prod. We want to make sure our CI picks up everything that it can possibly pick up before we merge the PR. So this includes formatting the code, validating the code, testing the code, doing some sort of policy check. And when I say a policy check, I'm talking about a business policy or a technical policy. For example, we don't want to deploy super large instances to AWS. We can prevent that by putting in a policy. Or if you don't want to use a particular AZ or a particular region. So from there, we want to do a plan. And after the plan, I strongly suggest, but it's not always possible, to do an apply. So if you can, and your company can afford it, do an apply in a throwaway environment and then destroy it. But unfortunately, the bigger you get, the more expensive that gets, obviously. So it's sometimes not possible. Onto CD. So continuous deployment to production. Now, what does this mean? This means hands-off deployment, where it goes from dev to test if you have it, to non-prod, to pre-prod, to production. And that means you don't touch it, it progresses through each and every environment. And after each deployment, you have a set of tests, a set of TBT tests that can validate that you've gone and you've done the right thing and there's nothing broken. So another thing that we see a lot of is unnecessary approvals. So let's say you've got your CI, you've gone and approved that PR, Luke. Thanks for approving it, by the way. Now, it's gone in and is ready for deployment. But for some reason, to get from dev to non-prod, you need to approve it again, Luke.
I'll go click that button.
Why? Yeah. So you've just approved something twice for no particular good reason at all. Get rid of those unnecessary approvals and let it go through. Okay, so another point is an all-in-one versus a split pipeline. Now, people are divided on this. I prefer to have an all-in-one pipeline, but then why not both, eh? So have an all-in-one pipeline, and then if you do need to have single pipelines for deploying to individual environments, for example, because I need a bug fix or something like that, then allow that too. But try and use that all-in-one pipeline that does each and every one of those environments for you. Finally, bug fixes and hot fixes. What should you do there? Well, I strongly recommend that you go through the environment progression if you can. If it's something, dire and you need to go through and push it into production straight away, of course, push it into prod so that you get your company up and running again. But I would much prefer to go through each and every one of those environments.
So this is the way. If we consider all of those points we've talked about over the last couple of slides, we tick all of the boxes for issues that we found in the other approaches and improve on all of those metrics we talked about earlier. We increase developer productivity, we reduce the amount of time it takes to get a change out and in front of customers, and it reduces the chances that a change is going to go bad and have a customer impact.
Not every place is going to be able to do what we've just outlined. So we're going to come across some constraints. One of them is being able to deploy to production. Some places require change freezes, change records, manager approvals, and other various business policies or other business constraints. So what can we do about this? We can start using feature toggling on, like I've described on the code structure slide. One of the important points of using feature toggling is that we don't want to bundle up a month's worth of changes and deploy them to production. Try and still deploy as frequently as possible. If that means once a week, sure, but if you can go down to once a day, even better. Apart from that, what else can you see, Luke?
Yeah, so one thing that's I've seen become a problem in multiple places is when there's the combination of not being able to go take a change all the way through to production and multiple teams owning config that's in the same state. So where this becomes a problem is, so Simon's team might go and add some cool new features in there, but they're not quite ready to go to prod with it. I've got something I've got to get out the door really quickly. I add that, but when we go to roll it out, either we're using a branching strategy and we can kind of cherry pick my change, but then we have all of the downsides we talked about earlier, or if we're using trunk-based development, which doesn't have these downsides, we end up with unrelated changes coming in. So a way to address that is really just to limit the ownership of the config that goes into any particular state to a single team. So at least then within the team, you can manage any differences.
So we really haven't talked about tools much at all, but here are some of the tools that I could potentially recommend for you to have a look at. Firstly, Terraform CLI. No back to front, it is the core piece of tooling that you will use when using Terraform. TerraGrunt, if you're a newbie to Terraform, TerraGrunt can create a layout for you that will help you give that environment progression. One of the downsides to TerraGrunt is getting away from TerraGrunt is a lot more difficult than using TerraGrunt. Terraform Cloud, it's fantastic. Try it out. TerraTest is another great tool. This is for testing your code. I strongly recommend using it. Further from TerraTest is ConfTest. ConfTest helps you do your policy as code. ConfTest uses OPA, so you can write your policies in Rego and then have ConfTest look at those policies and say yes or no in your deployment pipeline. And lastly, Terraform Docs. This is a fabulous tool. Why? Because I don't have to write doco on my modules. It automatically grabs the variables and the info in your repo and creates a nice README so that you don't have to do it. Yeah. So Luke, what are some of the things that we've learned through this presentation?
What I'm hoping everyone takes away from this are that if you carefully consider your environment progression strategy, you can have a big positive impact on engineering productivity, and you can help whichever organization you're working with develop quicker and more safely and more frequently.
Yeah, some of the technical takeaways would be simplifying your code is important, minimizing environment-specific code, making sure you apply your change throughout each and every one of your environments in order. Continuous integration and deployment is an absolute must, and we want to try and always reduce that blast radius. And we can't forget that if you do all these things, we're going to not only make the business happy, but you're going to make people like your managers happy because their world of governance is going to be less stressful. Security people are going to be less stressed because we're going to be providing a lot more secure, frequent deployments. And finally, risk. Potentially you can reduce the risk of issues to your production environment.
Yeah. And finally, you're going to be happier because you're going to be able to get on and do things that you want to do with a lot less hassle.
So, time for some questions. We're more than happy to answer them. If you don't get a chance to ask any questions, we're more than happy to answer them on LinkedIn. So please do reach out.